Okay, so the mole concept in chapter 5 is sort of the central idea for the whole chapter. And when people first started looking at atoms and molecules, they couldn't actually look at them. They couldn't, in fact, we really can't still. But we have a lot more technology now than they did back then, and they made a lot of assumptions. So Dalton is the first one that you guys are supposed to be looking at, and this number one question on page 77 is just kind of trying to give you an exercise in that you can kind of get into his headspace and understand what he was trying to figure out. So Dalton made some assumptions. He figured out that things were made of atoms, but he didn't know how many and he didn't know how they related. So basically what he did was he knew that hydrogen was the lightest of all of the known substances, because if he had a certain volume of hydrogen gas, it weighed less than any other gas of the same volume. So he assigned hydrogen a value of 1. It's not really 1 gram or anything like that. It was just like, hey, if hydrogen's 1, then what's everybody else worth? So what they want you to do in this activity is assign masses relative to hydrogen for oxygen, nitrogen, and carbon. So if, for example, we've got 11.1 grams of hydrogen, you can kind of see that that's a 1 to 8 ratio. But if we wanted to figure it out, we could put it in terms of what would this number be, right? So you just kind of, it doesn't really matter how you set it up, you're just setting it up as an equivalent fraction where hydrogen being the known thing, so this is hydrogen over oxygen is how we're setting it up. Hydrogen's the known thing, so it's that one. And then you could cross multiply and divide if you wanted to. This one, I can just visually look at it and go, okay, well 11 times 8 is going to be 88.8, which is close enough, so it's basically 1 over 8. What you could have done was go 88.9 times 1 divided by 11.1, and you'd still get about 8. So what we're saying then is that oxygen's mass, relative mass, is 8. So oxygen, well, let's put oxy on there, is 8. And then they get rid of hydrogen and they start comparing everything to oxygen. So we're going to say, well, oxygen's value is 8. And if you look at the periodic table, oxygen's value is not 8, and there's a reason for that, but we'll get into that stuff later. For now, this is what Dalton was working with. And if he compared this way, that's the results that he got. So, looking at this one, I can go, okay, well, 46.7 nitrogen over 53.3 grams of oxygen is going to have to equal something of nitrogen over 8 grams of oxygen. So we're just setting up that comparison. So if I had my calculator handy, I would be running these numbers. I could go 8 times 46.7 divided by 53.3, and I would get, obviously I'm going to have a number that's smaller than 8. So I get 7. Your book explains it a little differently. I like using comparable fractions. So nitrogen then is 7, and if I were to compare it to hydrogen, I would expect it to be 77.7, whatever. Okay, so moving on. Sorry, don't want to complicate things any more than they need to be. I've got carbon and oxygen now, so it tells me I've got 42.9 grams of carbon compared to 57.1 grams of oxygen. Now, knowing that oxygen's worth 8, I can set my equation up. 8 times 42.9 divided by 57.1, and I should get roughly a 6 carbon. So what that's saying is that nitrogen is worth 7 mass units, and carbon should be worth 6 mass units. Now, if you look at the periodic table, this is not the atomic mass of carbon, nitrogen, or oxygen. It's actually their atomic number. So there was a problem. And the problem was that he didn't know how they got together. He didn't know how many hydrogens, how many oxygens, how many carbons that there were. So the ratio part is missing. So this first little activity they got you to do is sort of trying to get you to understand the struggle that these first chemists went through when they were trying to figure all of this out. They wanted to take you through sort of an evolutionary process of how we got to where we're at right now.